I start slowly, everyone will join.
Yeah, maybe I can have some initial chit chat.
Yes.
So, so I appreciate everybody who has remained patiently in the second session also. So believe me, this will be useful to you, okay, especially the Paraview. Because when I started using Paraview, there was nobody to teach it. And you know, it's a very confusing software, particularly for beginners. The console is designed in a way that if some prior introduction is not there, there's a good chance, you know, you kind of start hating the software. Which is given the fact that, you know, most of the high-end journals, if you go to physics papers where people are doing, or mathematical papers where people are doing fluid dynamics simulations or some kind of PD is involved, then most of the figures are made in Paraview. So on one hand, you see all these people are making beautiful images and animations and present that in conferences. And you are sitting on the audience bench and you're okay, how the hell are these people doing this? Okay, you have the software, it's a free software, it's downloadable for anyone. You can install it also. But the question is how you're going to use it. So I believe that at least for Paraview, a beginner level introduction is you know, an ice-breaking session is fundamentally needed. So all the guys who has remained patiently, I appreciate your effort. This will be worth it. Okay. Secondly, I want to thank all organizers for organizing this wonderful meeting. Parth, Sandeep, all these guys were running around, you know, for last 1 week, making the arrangement, logistics. I especially want to thank Ratik for negotiating to get this room. We had a lot of things going on yesterday, and after a long fight, we kind of secured the room. So it was also my very heartfelt thanks for Ratik for doing this. Then I must thank my partner Rekha here. I must heartfelt thank her because Rekha has a very busy schedule this month. She is one of an invited speaker to a prestigious conference in Germany that is going to happen next week. She has 2 more conferences to attend next week, and she has to prepare for all this stuff. Still, she finds some time for talking about the final different schemes. So I appreciate Rekha your effort. Okay, no. So that's for the chit chat. No. So let's start. I believe that from the notes we have sent you a couple of days ago, all of you were able to download Matlab, either download Matlab or come to know that okay, there is a console that where you can use Matlab through Google Chrome or any other browser. So what you have to do is that type this address in the screen, in the address bar, that is matlab.mathworks.com. Of course, you need an LDAP ID that has to be registered in MathWorks with some password. So this procedure has been explained. I believe that all of you have done that. So if you haven't done, I think some of you must have installed the Matlab. Similarly, I expect all of you are in a position to run the codes. Can we take that granted? You can unmute yourself and say some responses, you know, somebody. Anybody? Okay, let me ask this question. There's anybody there who cannot run Matlab? No response. Okay, so I believe that everybody has access. So let's start typing the code. Okay, I understand that 50% of you are have some experience with MATLAB before, and 50% are beginners. So maybe I will go a little bit slow, but not very slow, but also not very fast. Okay. So Rekha will liaise with the chat questions. So there is the screen there. If any questions, immediately ask. Okay. So an introduction to MATLAB screen. So we have the editor screen here, which is you are showing in the window. So this is where we write the scripts that are the executable codes in Matlab. Okay. Once we successfully write a code, eliminate all the errors, then we will click the run button to run it. You can do via terminal also in Unix, but that is for extremely code savvy people. But this is for just introduction. So we can just press the run button to run the code. Okay?
Somebody has written that can't run Matlab.
Oh, I see. Okay, pretty much we cannot do anything about that now. So this video will be available on YouTube. So you have to maybe rewatch again, or so I believe that it has been circulated how to download Matlab. So let me go ahead. So this is the screen what we are seeing. That is the script screen or the editor screen where we type the scripts and run. Okay, all the commands will go here. Okay, so let me just run this code and see how does it look like. So it will ask for a change folder where the folder is located, and it will run the code. You can see a figure is generated here. Yeah, and it should show some results. Yeah, see. So this is a transport simulation I showed you. Of course, this is the code is running in Matlab. We will export this data to Paraview. For some reasons, I will explain you in the future course. And we will do the simulation. We won't do any coding in Paraview. We just need the data, and using that data, we will construct animations in Paraview. Okay, so this is how the results look like. We have an editor screen here, and we have a result screen here. It may be figures, it may be output, it may be numbers. Okay. So as of now, I'm just showing you an animation how the concentration is varying with respect to space and time. Okay, okay. So I wanted you the current folder, workspace. Okay. Let the code finish running. It takes some more time. One problem with online is it does not have some functionalities. It can run all the codes, but some of the toolbars won't work here. We will check here. Yeah. Here. Yeah, layout. I will take the three column default layout. Yeah, good. So this is done. So I will close the figure window. You can change, how you want to see all this, the command window, and so maybe I can put the command window on the top, so or you can separate it from it. Yeah, that's better. Okay, so we can see side by side. So is the writing visible to you? The code, scripts, and etc. Not visible? Please tell me. So this is the script.
You'll share it at the end, right? Somebody is asking to share this
code. Yes.
Every code should be shared, and every plots, every animation will be shared. No worries.
I mean, they are saying, I think, to share.
Right now. Then what I'm going to teach now? I'm going to share the code now. I will be jobless. Okay, you have to do the code,
We'll do it later.
Yeah, we will do that later. Okay, right now, I want you to write the codes. It's like swimming. I can give you swimsuit, and then I can ask you to swim. You have to swim, right, to learn swimming. So any skill is like swimming or cycling. You have to do the thing to learn it. That's the issue. So this is the command window where you can write commands. Okay, for example, all these commands in the script will also work here. I know for IKB guys, this will be very basic, but I'm just telling all things for the freshers. Okay, so please bear with us. We are a little bit slow. So okay. Now let's can you show the script, MATLAB screen here? Yeah, okay. So let's start writing the code. So whenever you start the code, just save it. Otherwise, you will lose the data. So let's save this file. I will call this transport. How do you make the new screen? Just press Control N. Sorry, I am very sorry. I haven't clicked here. Oh. There's a small plus icon here. So Control N does not work. Plus there, you'll get a new screen. Immediately save it. So we can type transport new. Okay. Now, what's the first command we have to do? Usually in every MATLAB program, when we open the window, there will be some saved variables or saved data already existing in MATLAB's memory from the previous calculation. So we should erase all those data. Otherwise, if we leave some undeclared variables already like that, for example, I may have a matrix A defined already. Okay, it may be a 3 by 3 matrix. I am going to add some more data to A. Okay, so what happens is that some of the data of A will be not useful to you. It will be something it is used in some other code. So this will create errors in your code. So the standard coding practice in MATLAB when you do is that always erase whatever variables already declared. So how do you do that? That's called clear words command. It's called clear variables in expansion, but just this is clear words. Okay. Then we may have a lot of writings in our command window. Okay. For example, I will have something like some calculation already done. Sorry. I can have something like 1 plus 2. That is 3. Okay. So MATLAB is a advanced calculator basically. So what you do is that we can, to erase all this calculation, I will just press CLC. Okay. So I will comment here also CLC. Maybe this I can increase the font size of the editor. So I will go to preferences and I will go to fonts. So there should be an editor. I think this is desktop code font. Probably better place. Yeah. So I will increase a little bit bigger. Make this 14. Good. So now I want to type what these commands do. You know what happens when you type codes is that you will type a code today. You will get some results. You will show it to your supervisor. 10 days later, your next supervisor will ask, "What is this code doing?" Or you have to explain to somebody. And believe me, this is one of the biggest curses in programming. You will not understand what's your code unless you comment it. What are you doing? Okay, especially when your code has many files, it's very difficult to understand what the code is running. So this is for clearing the variables. I have to go a little bit faster, otherwise the IKB guys will be angry at me. So this is to clear the screen. Okay. Now I just write format long. This is just for displaying the numbers in the long engineering format. There are other display formats in MATLAB. That is something called short E, that stands for short engineering. There can be format short, all these kinds. There is an exponential notation, all these things. Okay, so this you can check out. So format long stands for displaying numbers in the long format. Displaying fraction numbers in the long format. Now what we need. So if you remember Rekha's explanation today morning, we have to solve the transport equation defined over a time and space. Okay. So we need what's the initial time. We need what's the final time. So let's initiate that. I write t ini as 0. So my simulation is starting from 0 to 10. Okay. My final time. My t final is 5, which means that my final time is 5 units. Okay. Also I have to define what is my spatial variables. So these are my temporal variables. So let us write time variables. You can write my, now we will define our space variables. Okay, so this is x alpha and x beta, that is the starting and ending point of the tube. I will write xa equal to 0. So my tube is starting from 0, and xb equal to, I just write 2 pi. So that is my tube length. So xa is the starting point of the tube and xb is the ending point of the tube. Okay, now I will discretize the interval 0 to 2 pi into I number of distinct points. So I write I is equal to 500. What is that doing? It is, I want a construction, I want a command that can generate 500 equally distributed points between x and xb. Remember, this was the x0 less than x1 less than up to xi nodes like I explained today morning. How do we do that? That's the question. Okay. For this, there's a wonderful command that we can use. It's called Linspace. Okay. So it's called Linspace. What is Linspace? I'll show you an example. So if you type Linspace, the starting point 0, the end point, and the number of points you want in between, say 10, and you press enter. So see, it has created 0, 0.11, 0.22 up to 1. So you will get 10 points between 0 and 1 equally distributed. Maybe I can write 5 so you can see all the numbers. Oh, that's again a disaster. Maybe can we maximize this one? Yeah. See, 0.25, 0.5, 0.751. That's all the 5 distinct points in the interval 0 1. Okay. So let me go to transport new. Yeah. So what I am going to do is that I will define my x space, that is the discrete node space, as linspace xa xb I. Now you need what's the discretization factor, the spacing between 2 points. Okay. Can anybody suggest me a quick hack how you can find h without any division or multiplication or something? So I have my x space here. So x of 1 is the first point. How do you access the numbers of x space? I will show here. I can just type x space equal to linspace 0 1 say 5 points. So if I, oh my god, I take 515 points. Okay. So okay, something. Yeah. So if I type x space of 1, I will get the first point. Okay. If I type x space of 4, I will get the fourth point in that row. So to find the distance between two nodes, very easy. It's uniform. You just type x of 2 minus x of 1. Okay. So let's just run this code and see what's happening. Okay, it should be x space, and this should be also x space. Okay, I have to type this here also. Run the code. Yeah. So if you press H, you can see what is H. So everybody is able to do till this point. You can put your response in the chat box if you want to go faster or something, you know.
Yes.
Trace is okay?
Yes.
You are getting understanding the good things? Okay, very good. So let's go. Now Rekha said about the stability condition. How do you impose a stability condition? I always need delta by h to be less than 1. Okay. So we need the CFL condition that says delta by h is less than 1. So what we do is that we will define delta as h by 2. Okay. So my delta by h should be always half, which is less than 1. So my stability condition is imposed. Okay, you can make delta is equal to h by 4 or h by 5. Any number less than 1 will do. Why we are doing this? This is to ensure our scheme is stable. I will show you by putting delta equal to 2h that the scheme shoots up. Okay, then you will get a real feeling of this one. Now,
Gopi, what is the meaning of access space 2?
x space of 2. So x space of I accesses the ith entry in x space. X space is a discrete set of points x0, x1, x2 up to x capital I. You want to access the ith entry. So what you do? You just call x space of I. If you call x space of 13, you will get the 13th entry of x space. Got it? Okay. Now we have to discretize the temporal space into uniform points, into discrete points, such that the space between is h. How do we do that? So Matlab is very handy in these things. Okay, you just type t space equal to your t ini starting time, the space you want between two nodes, and your final time. Just this one. Okay, I will show you the power of that code. Okay, so go to the command window. Let's just type 0.1. Somehow my, oh, I'm sorry. My numerics pad is not, okay, I understand. It's a new computer, fine. So if you just type 0.12, see, it will generate points between 0 and 2 such that the distance between 2 points is always 0.1. 0 to 0.1 is 0.1, 0.1 to 0.2 is 0.1, up to you will get up to 1.92. So what does t space do? This will divide t ini, the interval t ini, t fin into points such that space between distance such that difference between 2 points is always h. Okay, clear? Now we need what is the length of, what is the size of how many points are in this space. So we can use a command for that one, which is called the length command. There are two commands in Matlab that will give you size of a vector. Okay, one thing is you can just call length of t space. What it will do is that it will give the longest dimension. Okay, now this is just a one-dimensional array, so it will just give the number of entries. Okay, look at here. I will just show you an example. I will create a vector. A is equal to 1, 2, 3, 4, 5, maybe 11, 15. If I type length of A, I will get number of elements in A. Okay. Now look at another thing. I'm going to create a matrix. Okay. A equal to 1, 2, 3. First row. To get the second row, put a semicolon inside the square bracket and type the next row. So this is a 3 by 3 matrix. Okay. I shouldn't have made a 3 by 3 matrix. I should have made something. Yeah. So A is a 4 by 3 matrix. So if you type size of A, comma 1, you will get number of rows of A. See, I got 4. So size of matrix comma 1 indicates the row number of rows of the matrix. Size of A comma 2 give number of columns. So instead of length of t space, you could have also write size of t space comma 2, number of columns in the t space, which will also give you number of elements. Okay, so let's go with the simplest one. This give number of elements in the t space. Okay. Now we need the current factor. So I will just current number. I will just write this is equal to delta by h, which we know already it's half. Okay, that's how we defined it. So not big deal. Now we need we have to understand the matrix initialization concept. We have to store space in Matlab to store all our data. Okay. Now, for each time point, for each Tn, which is a member of T space, we will get a space variation. That is a value U0n, U0n, U1 up to Ui capital N. Okay. So for each n, we have I number of values. We have such capital M number of values. So how do we do? We will store this as a matrix. Okay. So I will show you there are many ways to initiate matrices in Matlab. The easiest way is zero way. How do we do this? So if I type A equal to zeros of number of rows you want and number of columns you want, it will create a zero matrix. All entries 0, but columns will be, there will be 3 rows and 4 columns. Okay. There is another one which is called ones. So if you call ones 3, 4, you will get a matrix which is composed of all ones with 3 rows and 4 columns. There is another one which is called rand. If you call rand 3, 4, you will get a 3 by 4 matrix with some random numbers. Okay, as the entries. Okay, so we'll just write UH.
T space is increment in the time variable.
Yeah.
You have written the H.
Oh, sorry. I'm very sorry. That should be delta.
Himanshu pointed out.
Yeah, thank you, Himanshu. Appreciate it. Yeah. So UH will define as n number of rows and I number of columns. Okay. Okay.
Are you looking to the chat now?
So this is to store the solution. Now we have to impose the initial condition. How do we do that? Okay. So the easiest way to do is to run a for loop. Now what's the for loop structure in Matlab? For loop structure in Matlab is very easy. You just type for which variable you are indexing, its starting point, its ending point. So I need up to I and end. Okay. Now what I'm going to do is that UH of first 10, that is n equal to 1. Ith value I will define as, we have the initial condition already stored. I will tell you what is U ini of the x value. So I will write x space of I. Okay. So this function, this command will evaluate U ini. Okay. So this is how the computer understands. Oh my God, there is a for loop here, and this for loop is starting at I equal to 1. What it's going to do? It will enter the for loop. When it enters the for loop, it will see this command UH1, I is equal to UNI x space of I. So what it will do is that first it will put I equal to 1, and it will store, it will compute what is UH of 1, 1. What is UH of 1, 1? It is defined as UINI of x space of 1. So it will look at what is x space. It will find x space as a vector. It will take the first element of that x space, and it will evaluate the function UINI at that x value and store that function value as UH of as 1, 1. Then it will increase I to another by 1 level. That is to take I is equal to 2. Then again do this activity. Till I is equal to n, it will do this activity. Okay. So we will get the discrete initial condition for the scale. Now, what is UINI? UINI is our, take current folder and I will open UINI. Okay, so this is initial condition. So this is how you write functions in Matlab. Okay, how do you write function in Matlab? It's very easy. I will write another function for you, that will be easy. So always start with the tag name function, give an output, this is my output, and give the function name. My function name is going to be I don't know, square. Square is already in Matlab, so I will write my square. Okay, I want an input x. Then you define what's your output. My output is x square. Put a semicolon to compress the numbers without, you don't want to display unless if you don't want. Okay, save this one. in the exact name of the function. You should not write some other name. Whatever name is your function, you have to save in that name. So this is my square. Okay. Okay. Now let's see. Let's just evaluate my square of 3.4. See. So that's how you compute function. Similarly, u in e is the initial function. The initial condition we are solving. I'm just taking that as sin pi x. This says that the initial concentration is sin pi x. Maybe we can make it positive by typing absolute. So up stands for absolute. Okay, so that is the modulus values. This is to ensure that the concentration is not negative. Okay. Okay. So any questions till now? Do you have to go faster?
How to reduce space to 3 significant values, 3 significant digits? How to get it?
Space to?
It's like I think I have to get the 3 significant digits. That's what he wants to say.
You have rounding option.
Rounding.
Yeah, but that does not have any direct relation with our code. But there is a round command in Matlab. You can give how much accuracy you want.
Please explain size of a comma 1. I think a is another variable defined.
Okay.
You must have defining somewhere comma.
Okay, I will explain what is size command again. So you define a matrix A. I am going to define some rand matrix, 5, 6. So how many rows are here? Some answer? 5 rows, isn't it? How many columns are here? 6 columns. I want to know if I given with an arbitrary matrix how many rows and how many columns it has. So if you call size of A, 1, you will get how many rows A has. So what will be the answer here? It will be 5. Row size of A. How many rows A has? If you call size of A, 2, that will give you number of columns A has. So what is the expected answer here? 6. Is that clear? If it is clear or something, you just give a message in chat box.
Where we use
So
random
where we
function.
use random function.
Rand. Okay, rand is this command. Rand is is a inbuilt MATLAB command. So if you give rand of n, m, it will create a matrix composed of random entries of size n and m. It's an inbuilt command in MATLAB. It's very useful, when you want to check matrices calculations or something. When you want to create something which has no order.
So another question from Sajid is, we don't have to mention incrementation value in Matlab?
No, we don't have to. You can mention, by default it is 1.
Default.
Yeah. By default it is 1, but you can mention if you want.
Okay, another is from Amit Ansal. If you don't define...
No, that's answer. That
is
he
answer.
actually
Okay.
answered the same.
Okay, fine.
Okay, yeah. Now let's write our scheme. Okay. So you see, we have to write for a loop over the time indices. So I will try to start from 1. What Rekha told, we have to go up to n-1 this time. Okay. We know what is u1. We can calculate what is u2. Then u3. How do you do that? Okay. I will start another loop. Now, we have used so many for loops. Now let's learn how to use while loop. Okay. While loop does not have this increment structure. It's a little bit humanoid kind of thing. You can make it suit your convenience. Okay. So I will start with I equal to 2. Why I equal to 2? Because your indexing is MATLAB indexes starts from 1. In our code, in our lecture notes, we started from 0. But MATLAB cannot identify 0 as an index. So now while loop is like this. While you give a condition, I say you run this loop till I is less than or equal to capital I. Okay? And if that condition is satisfied, you do the following. What was our scheme? Our scheme is I want to find the value at n+1th level for ith index. How is this defined? This is your ui n+1. This is ni. What was that? Minus the current number times ni minus UH n I minus 1. Okay, then I have to tell while loop how to increment I. I say, okay, you redefine I as I plus 1. So I will explain how the computer understands these things. Okay, let's go to the mind of the computer. Computer will show this. Okay, oh my god, there is a for loop. I have to run this for loop. Okay, I will start from n equal to 1. It will go inside. When it go inside, it will say while loop. Okay, what is starting? The while loop is starting at I equal to 2. So now I have n equal to 1 and I equal to 2. It will test whether the while loop condition is true. 2 is less than or equal to capital A. Capital A was 100. So it can enter the while loop. So while loop door will open, it will enter the while loop and it will execute the command inside the while loop. It will start n equal to 1, so I have to calculate n plus 1, so that is 2. I have to calculate UH of 2i. How will I calculate UH of 2i? Oh, that is written in the right hand side. It is UH of 1i minus lambda times UH of 1i minus UH of 1, 1. UH at 1th level is known to us. We have computed that already here. Okay, and it will run the loop. So everybody is able to type up to this stage, understand up to this stage? Any questions?
No, it's okay.
Okay, yeah. Now I will show you what is a plot command in Matlab. You want to see how the solutions look like. Okay, so I will write plot. For each n, I will plot the variation for the constellation of between x and the constellation. So I will write x space. So x space is my space variable and the value at that point. So I will take nth value and I put a semicolon. What does that do? Okay, so this is something we have to explain. If you write A of, look at the matrix here, we have the matrix A here. If you write A of 1 comma semi full colon, it will generate you, it will give you the first row of A. If you give A of 3, it will give you the third row of A. So how do you calculate the column? Switch the places. If you type semicolon comma 1, it will give you the first column of A. Okay, so see, this our UH structure is like this. For we see it composes of zeros and then we are updating it. If you take the first row, it will give the value at the first time, T0. If you take the nth row, it will get the values at the nth time. Okay, now I am going to plot this. You just type plot your x value and your y value. Okay, and I want to just pause this. Okay, for a few time, I just want to see what's happening. I'll just give you a 0.1 time flag. Now let's just run this and see what's happening. See? I cannot find node, so I will do one thing. I will just type here. That's an error. So, are you able to generate this plot?
Please share the uni function again.
You type one function on your own. Take, I can display the uni.
Unrecognized function uni. You have to save that function.
You have to save the function. You have to save the function in the same name of the function you have given here. Do not save uni as.
And in the same folder.
In the same folder. If you type a uni function, do not save it as something like some else name. You have to save the function name should be uni.m. In the same folder. is post it. Okay, you can maybe it should reduce the time to a little bit smaller, 2 or 1. Otherwise, it will run forever. Okay. Any questions, guys?
Yes.
Yeah.
You can ask anytime, even not in the chat window. You can ask by
Can
unmuting
you please
yourself.
re-show unifunctions in
Any initial function?
unifunctions in
So take your time and code it, understand it, ask if you have any questions,
And Gopi, it is not mandatory that we have to stop at 12:50.
Yeah.
We can go onwards, Yeah, 15-20 minutes is okay.
Understand the things, otherwise you have to make use of it.
Invalid expression. What is it when calling a function on indexing?
What is line 30 for that guy?
That's what I'm checking.
Can you copy that line and ask him?
Okay.
What is his name?
Karan.
Karan, can you copy and paste that line where you're having an error in the chat window? We'll have a look.
He says it's working now.
Working now. Good, very good. Okay, now let's do one thing. Let's make delta as 2h. So clearly our CFR condition is not satisfied. I'll just run the code. Oh, why is it asking to save this again? Oh, I have to save this. Yeah. Did you see the instability? We broke the CFR condition. Look, it's shooting up to 10 power 8, 10 power 11. So that's what I said. No, you have to always satisfy the stability condition.
You are getting positive values, right?
Yeah.
It's saying index in position 2 is invalid. Array indices must be positive integer logical values. So second position is I. I is varying from?
I is varying from. Let's just check. Length of I. Sorry.
I minus 1 you are giving, so I varies from 1 or 2.
I varies from 1.
How can it be 1?
Matlab has, starts from 1.
No, but we have I minus 1 indexing there, no? So
500, yeah. So there is an issue.
no, I is starting from 2 copies, so that's it's fine.
Yeah.
Hmm.
Yeah. Let's go. Fine. Okay, so that's how we solve the transfer equation in Matlab. Okay. Always remember, let's make again h back to h by 2. Now, what you want to do is that you want to save this data to solve, to plot in Paraview. How you are going to do that? That's the next question. Okay. Now, Paraview is a visualization software. It's not a coding software. So what we have to give to Paraview is the data that we want to do. Okay. Specifically, we have to give the, so we have to give the variation of the concentration with respect to space for each time index. We have T0, T1 up to Tn. We have to give the variation of space, the space variation for each time index. So we have to write this as separate something called, now Paraview can accept different types of data files. Okay, can accept CSV files. What's a CSV file? CSV file is called comma separated version, which means that you can each entry will be separated by commas. Okay, so like that you have to create CSV files for each of your tables. How to do that? We are going to learn two things by doing this exercise. How to write something from Matlab into a text file or a CSV file, so that you can use that in another code. Okay, and how to export that. So let's do that. Okay, so first thing is, I will show you very simple example how to open a file in Matlab, and maybe I will write that in a different code. It should be easier for you. Okay. First, what we need is that we have to open a file. So this is a file writing exercise. So this is file writing, write.m. Okay. So let's take a matrix, create a matrix A. So I clear everything. I clear my variables A, and I will define A as random matrix. I will give 5 rows and 2 columns. Okay, I will create a random matrix of 5 rows and 2 columns. I want to write this into a comma separated version. How do I do that? Firstly, this is a legacy of C++, something that is inherited to Matlab, Python, Fortran, everything from C++ or from C. First we have to say is that we have to define a name of the function for the file we have to save it. Okay, I am going to define a name. My file name is something like, always give the strings in inverted commas. Okay, so what I have in quotes. So my file name is I give data dot the extension you want to say called CSV. Okay. Now what you are going to do is that we will open a file which is called fopen with that file name and give it write permission. To give write permission, put W in commas. Okay, are you up to this stage, everybody?
What is the name of book by Bartle? Bartle.
Numerical approximation of partial differential equations.
He has explained the codes and all that.
Yeah.
Numerical approximation.
So anybody has any problem?
Numerical approximation.
Can you explain the last line? Fopen. Yes.
Fopen will open a file with file name. Okay, so it will create a file in the directory on which file write is saved, and the file name will be data.csv, and we are giving Matlab permission to write something into that file. This data is a property of the computer, so it will not allow anybody to tamper it. So we have to give permission for this one. So there is RRW permission, read, write, and read. What was that? Read, write permission. So W stands for write. Okay. So you have to give the permission for Matlab to write things into that. Now, so we open the file now. So the file is now created, and it is Matlab opened that file, and we have given permission for Matlab to write into that one. Okay. Now, how do we write something into this one? Okay, so for example, I will run a loop for I equal to 1 to what is the, okay, I will write up to size of a comma 1, that is number of rows of a. Now what I'm going to write, yeah, this is a write command, f print f, file print function. Okay, now we have to give to which file we are writing. We are writing to file name. Now we have to assign spaces for whatever I am going to write. Now what I am going to write is the two entries of the matrix A. Okay, so first thing is space assignment. Now there are so many data structures in data types in Matlab, as Rekha explained in morning. We are going to write as a double numbers. Okay, so I will write percentage. Percentage means assign the space. Okay, I am going to assign the space for numbers of the form 4.4, which 4.4 D, which means that I am assigning 4 space to write a number with 4 places before the decimal and 4 places after the decimal point. Okay, so percentage means space assigning operator. And then I'm going to give, I'm going to put a comma. So I will write 2s. 2s means save as a string and put 2 spaces to write whatever string you are going to save there. Okay, then again a space operator 4.4 D. Now we have to tell what all things we have to write on these spaces. In the first place, 4.4 decimal places, 4.4 double space, we write A of I comma 1. In the second space, you write a comma. In the third space, write A of I comma 2. Look at that, the Matlab variables we haven't assigned any commas. Okay, so I will read the command again just for you to understand. Okay, so I have to, sorry, I have made a mistake. I have to give a string name for f open. So this is my current file. It's not file name. It's always the f open name. It's very sorry. Yeah, now that should work. Okay, so it will open current file. What is loaded in current file? The current file handles file name. What is file name? That is data.csv. So it will open data.csv and the internal name is current file, and to current file or to data.csv, think in that way. It will write the following entries. Okay, now I will run this and finally I have to close everything. After all writing operation is done, I have to close the function. So I will close the current file. Okay, close file. So let's run this. Okay, so let's go to the current folder, and there is something called data. Let's open data. This not showing me. We have download this one. You can download things from Matlab online. So what you have to do is that to go to the Matlab drive. The Matlab drive is something associated with Matlab online. Okay, all your functions files will be saved in a drive folder. So just go to drive.matlab.com. You can access all this. So I will just download this one. And will it download? Yeah, download. Just save there. And I will open data.csv. Just give it a time. It will open as an Excel sheet. Oh, I forget something. Why what I wanted to write as a separate lines, but did not do that, and now I understand the problem because I haven't given the next line operator. So that's the next line operator. that is /n. So whenever something is written, it will go to the next line. Okay, now I will run this again. Okay, so now I will go to current folder and I will open data.csv. See, you can see number, comma, and the next value. Next number, comma, next value. Okay, so this is A. So the first value of A, then a comma, second value of A, second, then the next row, comma, third row, comma, second column, like that. So that's how you write something from Matlab into a CSV file. Okay. So let's go to transport again. Yeah. So how do you do this here? Okay. I want to write everything from n equal to 1 to capital N. So let us write for n is equal to 1 to capital N. Then I'm going to give a file writing operation. Okay. So firstly I will give a file name. So everybody understood file writing? Anybody not got it? Any questions?
Answer.
Please tell me, because this will be used in the heat equation also. Everything clear? Fine. So let's quickly write the next one. So for each n I have to create a name. Okay, so how do you do that? So I'm going to make names of the form percentage, data 001 for the first one and data 002 for the next one, etc. How do we make these names? Automatically. That's the first challenge. Okay, so there is a nice command in Matlab that is called string print. Okay, so I will just write my file name fname as sprintf. So it will print a string internally on Matlab. It will not display it. Okay, but it will assign a name to grid name. What I have to do is that I will create a folder called output. On that output folder, okay, on that output folder, we will create data. Okay, now on the end of data, assign 3 spaces. I will give 3.3d.csv. Now on the 3.3.csv, put n. Okay, so it will, whenever n is 1, it will create a file name called, it will create a fname called output data 001.csv. That's called string printing. Basically, it concatenates a string which is the output data with a number, that is n here. Okay. Now, now how do you do this? Firstly, I create a matrix as we did previously. I will type x space prime. I will access the x space prime, that is my space, but it's a row, so I am putting that as a column so that I can run over ith entry. Okay, and I put the next column as the value of the solution at nth level. Okay, now I am going to write this. So a will change with respect to each n. Okay, when n equal to 1, it will be UH of 1, when n equal to UH of 2, etc. and etc. Okay, now I write fname, the function name I want to write. So I will open a file. Sorry, fname I already used. Okay, so I will give my file equal to f open grid name. Sorry, fname. That is the string I created here, and I will give it write permission. Okay. Now the problem here is we don't have an output folder here, so we have to go to drive and create an output folder here. So I will create a output folder. How do I create a new folder? You rename. Need to delete. Okay, I think Matlab drive codes Yeah, no folder. Just type, sorry, Matlab drive, codes VGC, transport, new folder. So output and create that folder. So whatever we are going to say will go to output. Okay, so let's go here and continue. Yeah. So now I will write again our file writing I equal to 1 to capital I, 1 to capital I, and so here I will write f print. Let us just copy from the other place. Okay, in the file write. Because this is easy. Go to transport new, and I'll just paste here. Now here I will just give a of phi1, a of phi2, and there is a space limiting operator, and I will just close my function. F close my file. Okay, so let's see the result. Then you will understand what we have done here. Just run this code. Oh, I haven't saved. I reduce my time to t and h to h by 2. So let's just run. And u ini is absolute, and what is u left? U left is it's concentration here. Okay, so this also I will make absolute of sign minus 30. Some numbers, okay, it's a pseudo numbers. So to run this one.
So there is one question. For fixed time, okay, we have created the animation corresponding, evaluation with respect to x. So can we do that to create a sequence of plots as an animation where each plot corresponds to particular time?
Yeah. You can. Instead of the time, you can do space. You can move over space. You can get the friend. But he's asking the other way around.
No, it's not other way around. We are just fixing time and looking at the evaluation with respect to the space variable. Now, how with respect to the time evaluation, I think it's like appending. No?
Yeah.
It's like appending.
Yeah, we can do that. It's actually, if I understand, you are saying that instead of space data, you need to get a plot over the time, and then vary space, right? Who's
Shreyas.
Shreyas, could you explain what's your question? It's a little unclear.
No, I meant precisely this animation that is visible on the screen currently.
Yeah, I meant that the animation on this current screen is the time evolution of the spatial concentration, right? The plot that is moving. Yeah, I just wanted to know that how to do that. You just did that. Yes, that was
Okay.
So now let's go and check our the code is completed. So the command window says okay, there is some error. Okay, I should give UHN prime also here. That was a mistake. So let's run this loop only. So already the other part is done. We don't have to spend too much time on that. Yeah.
In that 51st line, you should be writing that in my file. You are writing it in.
Yeah. Thanks. Very thanks. Yeah. That's why it's not right. Current file is done. Yeah. So this is an error that happens when you copy paste carelessly. Exciting. Did finish it? See, it's writing all the name files. 103. We'll just show how to. I will just show how we can plot this in Paraview and do the animation and stop current session. After the session, we will directly go to solving Poisson equation and then making animation for heat equation.
What file we had to make in the Matlab drive?
What file you have to make in the
Matlab drive.
Yeah. So look at the current folder. So what I do is that I will go to drive and I will just download the output folder. So download blocked. Allow always download. So you can download the Poisson code. I will save this one. So that is being. Let's go to the output folder here and extract it here. So now I will show you how to use Paraview. So I will just extract. How do I extract over here? Extract on. Yeah, very nice. Good. Now go to output folder. See, you have all these data files here. Okay, so each one corresponds to each time file. Okay, now what we'll do is I will select all of them. Now this is the Paraview console. Where is the Paraview console? Okay, so you have. I will explain a little bit more detail. This is my data rendering area, the gray one you see, and there's a property bar here. Okay, there's a property bar here, and there is an information bar here. Okay, and then there are some menu bars. So there are a lot of functions, filters. Don't worry about too many things. There is a camera positioning, all these things. So Paraview is a very professional software. It's actually for making real fluid dynamics animations. So there are a lot of amenities we can avail, but just concentrate. There is an animation bar here. There's a property bar here, which where we can give the attributes of the plot, and there's a rendering window here. Just keep that in mind, and with that minimal knowledge, let's try to make an animation, a very simple animation, a time evolution. Okay. So what you do is that once you download output, select everything, drag all of them, and put into the rendering view. Okay, so there is a data here. So what we do is that we will apply it, click apply. You haven't seen anything because we haven't applied it. Okay. So it will show what kind of data we are using here. It takes some time, it's a little bit heavy. Oops, my Paraview crashed. I'll lock on that again. Sorry. Sometimes this happens with Paraview. I'll do one thing. It seems this one is a little bit slow. I will share my other screen. Okay. We'll just.
We are answering these questions in chat.
Just stop this one and go to my Zoom room, and I will share my Paraview screen. Can everybody see this one?
Yes.
Paraview?
Yeah.
Okay. So now what I do is that I will again I have to go to Matlab online, drive.matlab, and download the data there. Okay. So
so let's see also that how we can take the break.
I don't think we can move up to 150.
Yeah, maximum 115.
Good, 10 minutes.
Yeah, I will mention 10 minutes. Or I have data already. I will just show you how to do this without downloading or anything, it's expensive. Yeah, so as I said, go to the output. I think I have some output, PGC materials, codes, PGC. There should have been an output, miscellaneous. Oops. Somehow I have to run the code again. I'm very sorry, guys. I have to create another function output.
Yeah, so someone is saying to repeat the how to import Paraview.
Yeah. I'll tell you. Just looking where my Matlab is. This file is transport. Okay. Don't worry, it will go slowly. Codes PGC transport. Okay, I have to make an output folder here. If I don't make an output folder, it will not write it. That's the issue. Folder output. Okay. Minimize this one. Can you see the Matlab window?
No,
Okay.
this is Paragraph.
Yeah.
I'm mentioning
Maybe
this
even
to
just stop share.
We'll go for the
Share and
lunch break at 1:50.
That you will.
1:15 in next 10 minutes.
can you see the Matlab now? Yeah. Okay, so the code is running. Is it running? Yeah, it's running. Empty. So there's too many points are there. I just close it and reduce 100, maybe to 100. Yeah, I can reduce it to 2. The figure should be here. Yeah. Yeah, it's done. So let's go to output. Okay, the guys who asked what you have to do. So we'll create this data. Okay, CSV files. Select all of them. Okay, and open the Paraview console. The folder is here. So what you have to do is that drag all these files into the Paraview console. Okay. Then what you do is that go to filters, alphabetical. You are going to see a huge thing. Okay. So there are so many things here. It says these are different things to plot different types of data structures. We just need plot data. You just click plot data. Okay. And we can see the functions. But there is an issue. Okay, let's close all unnecessary windows. We don't need render view, we don't need data view. Okay, I have something also. So let me see. There's a red line here, and there's a blue line also here. Why I don't understand why there's a blue line here. It's because there is an unnecessary file in the data one. But let's ignore that. So what it does is that it will plot the x-axis, the first column and the second column all together. Okay, so we don't need the first value, okay, the x value, so we can uncheck that. Okay, so there is a series parameter column here. Check x value. Okay, and look here, there is a use index for axis. Okay, now it is plotting against the number, the index number. You can see 100 here, but we want to plot against the x-axis. So uncheck that and change x array name to x value. Now you will get this one. Okay. Now there is a play button here. Just click the play button. Click the play button. See, it's creating a frame by frame animation. Okay, I have only 31 frames now, just created just for showing you. Okay, see. Now you can play around with this thing. Okay, so basically this is the instructor's role is up to this stage. After that, this is self-learning. So you can increase the line thickness, its style, all attributes. Okay, I will just give you a axis title, that is concentration versus space. Okay, and you can give change its fonts, all these things. Okay, you can make axis titles here. That's a left axis title, so I will just write concentration, and the bottom axis title I will write space. Okay, left the other things I leave to you, experiment on it. You can increase the, you can give a color to the axis. Okay, most of the commands are very self-explanatory. You'll see now the x-axis is in blue color. Okay, you can give color to the titles also. Now the important thing is, how do you save this as an animation? That's what you want to know. So go here and click on save animation. Okay, and select some folder where we can actually save. The problem with bit files, I'll go to just desktop, or okay, and I'll just type no desktop, I'll go to my documents, and I will just type, you know, trans new, and I have to save that as an AVI file. So save it. So it will show, I think it has already saved. Now let's check. We have to go to I don't know, so many things are running in the computer, so it's becoming a little bit slow. Yeah, I don't know, it got stuck. I think it's wrong. Maybe if I stop share, I can see. No, still it's dead.
क्या हुआ? चल रहा है कुछ?
I'll share again. I have no idea. So I'm very sorry, my PC is stuck. So let me check the problem. So I think you got the idea. We will see after the live session again how this can be done. Maybe
repeat the.
Yeah, I will repeat this again once more. The animation.
So okay. Is it okay to go for?
Okay, maybe we can take some questions.
Okay, friends, we can have some question for maybe 5 minutes, and then we will go for the break. If you have, you can ask, unmute yourself and then ask.
Can you explain that line 47 again? See, in which you are creating the matrix A, compiling the data before writing. What that single inverted comma stands for and why we use it.
Prime. That is stands for the. I want to create a n by 2 matrix, a matrix with I number of rows and 2 number of columns. So the array we have created, X space, that's a row. Okay, that's something like n 1 by n type matrix, which means it has 1 row and n columns. I want to transport that into a column matrix, which means n rows, I rows and 1 single column. So what we do, we do transpose. The prime stands for transpose. You can, it's just a matter of convention I used. You can to make a matrix with X space, X as the first column and the function data as the second column. You can make the X data as the first row and the function data as second row. That also does the job. But then you have to, these are two separate rows. So instead of giving a space, you have to put a semicolon. I will show you that afternoon. What's the difference? That's a nice point. So to answer your question, prime stands for transpose, matrix transpose.
Yes. So any other question?
So while we are plotting this, can we also get a simultaneous, a time value over there, like for what time instance?
Yes, you can. You can give a legend entry. I will show you.
Legend entry. Okay.
Yeah.
And also, can be annotated later on, like how we do in Python and all, like annotating the figure. Like, can it be annotated a certain point or anything? Something we want to overlay onto the animation.
Yeah, you can. There are many things you can do. All this one. But mainly the Paraview data is the primary usage is to make animations for 2D and 3D data. Especially it's for finite element analysis when we have triangulated data. This one I just show you as a beginning example what Paraview looks like. So a little more serious example we will do afternoon. That's the heat equation simulation.
Thank you.
So I think we can break for lunch.
If there is no question, then we can go for the break and we'll meet again at 2:30. If anyone have, then let's ask.
So if there are no questions, then we can break for lunch and we can rejoin at 2:30.
Yes, take a break.
Okay, guys, see you at 2:30. You can all have a lunch and then we will come back and rejoin for this session.
That's what my RAM is already.